Okay, to review regression analysis, correlation and regression analysis, I'm going to go back and forth between, I'm going to rotate through the handout and Excel and PowerPoint. I won't spend much time on the PowerPoint. It's, however, been edited and should be useful to you. You might want to take a look at it. So here's our handout that goes through the example with the shoe print length and height of 5 men measured in centimeters. And so don't forget, excuse me, that it's very important that these values are paired up, so that, for instance, this man's shoe print length is 29.7 centimeters. His height is 175.3. So when you enter them into Excel, as you should, you want to make sure that these two are next to each other, and these two are next to each other, and these two are next to each other. I put them in a column because that's what I'm used to working with. And so this example, I believe, kind of follows the things that we're asked to do in that take-home question, which I think is number 7, as I recall. Anyway, these are the instructions for how to execute all of this. And we're told to highlight both columns of data, click Insert, then click Charts, and etc., etc. So this is the output that we will get when we're done. And now I'm going to go to that Excel spreadsheet so that I can go through all those steps, and you can see them up close and in detail. All right, and so you see in this spreadsheet that I've created here, I've already typed in the shoe print lengths and their corresponding heights. And the first thing we're asked to do is to create a scatter plot. So to do that, you click Insert on the menu bar here, and you highlight the pairs of data. You don't need the labels. You can use the labels, but you certainly don't need those. And then once you've highlighted all the pairs of data, then you come up here to the recommended charts, and you hover over this little guy there with the blue and yellow dots, and you'll see that it says XY scatter. When you click on that image, you get various options for scatter plots. We're going to use this one here, and so you click on that image, and that gives you just a plain ordinary scatter plot. So here's the man with 27.6 centimeter shoe print, and he is 172.7 centimeters tall. So you can change the size of this if you want, to as small or as large as you'd like. And you can also, if you, as it's in this state, if you click Control-C on your keyboard, if you, not click, but if you type Control-C, that will copy this image. And then if you have a document, a Word document, or whatever word processor you use, then you type Control-V. If you use an Apple computer, if you use Mac Pages, that's Command-C and Command-V. But for right now, I'm just going to delete this and get it out of our way so that I can move on with the next task. Now you're supposed to evaluate this for a potential linear relationship, and I think we all decided in class that there's not much of a linear relationship there, and turns out, as we will see shortly, that was correct. So I'm going to delete that, get it out of the way, And I'm going to click away from these selections for the next step. And so all of this, my 1, 2, 3 here, are all, they all describe the steps that I'm about to take in my Excel spreadsheet. So at the top of the page here at the menu, in the, what I think is called the menu bar, you click Data, and off to the right here you click Data Analysis. Now if you don't have Data Analysis added in to your copy of Excel, you can do that. It's not hard. Just go online and Google Activate Data Analysis Tool Pack. Activate Data Analysis Tool Pack, and you can find any of a number of YouTube videos that'll show you how to do that. So when we open up Data Analysis, we want to highlight Regression and click OK, and that will give us this dialog box. Now there's a cursor here in the input Y range box, ready for that input. The heights of the men that are going to be the Y values. So you click the first one and drag down to the last one, and that puts that array into the dialog box here. Now you need to click away from that directly into the input X range in order to then input the X values. The X values are the shoe prints. So you click the first one, left click, and then drag down to the last one. And so there you see the X values, the cells that the X values are in. If you did click on the labels, you would click labels here, but we didn't do that, or I didn't do that here. And now you need a place to put the summary output that we're going to get after we click OK in a second. And so you come down here to Output Options. If you leave this checked, what you're going to get is a new worksheet down here. It's going to add a new worksheet, and the output will be in the new worksheet. If you want to do that, that's fine. But I'm just going to click this bubble here, Output Range. That means it's going to go here on this sheet that I'm working on now. Then I have to click, you saw how it highlighted the dialog box for the Y values. So I'm going to have to click away from that. I'm going to have to click into the dialog box that I actually want to tell Excel where to put this. So I click in that box, and you see that I've chosen D1. I haven't told Excel that yet, but I'm going to tell Excel that now by clicking that cell. And so we're going to get our summary output, the upper left corner of our summary output there in cell D1, and then a bunch of cells are going to fill in down here with all kinds of statistics, most of which we don't use in this class and don't know, what to do with just yet. And so I click OK, and there is that summary output. Now you can see over here that you can't read all of these labels here. So if I bring my cursor right here to the boundary between column D and column E, I get this left-right cursor, and if I click and hold that, I can drag it across until I get till I can see everything I need to see. The width of the column can also affect how far all these values are rounded. I think these are probably rounded sufficiently. You know, they're all okay. And now I'm going to click away from here for no reason other than I just don't want all that grayed out. Now, back in our document, you see right here the same thing you see in Excel under Summary Output, Regression and Statistics. You see multiple R. Multiple R, that is our Pearson's linear correlation coefficient, little r. It's the test statistic for this example. So that's the test statistic, and that's the first thing we're asked to do in the question, is to identify the linear correlation coefficient. Now we're asked to conduct a formal hypothesis test. Well, the hypothesis test for linear correlation is always the same, and it is that rho is equal to 0, which means there's no linear correlation. Now, rho is very seldom equal to 0, but that's what we use for the null hypothesis. And so rho, this P-looking thing, is the Greek letter R. So that's the population parameter. It's the population version of the Pearson's linear correlation coefficient. And of course, if it's 0, that means that there's no correlation. Now, let's go back to the document. And the next thing we're asked to do here, yes, it's, as I think I already said, we're going to conduct a formal hypothesis test on this value of R. Well, we need a critical value, and so to locate that critical value, we use this table, table A6. It's part of the pull-out card that you got with your text if you bought a new version, or if you bought a used version that no one had bothered to pull the card out of. And it's also available in the at the formulas and data link that that I have posted on our school website. So we have 5 pairs of data. We have 5 men whose feet and heights we've measured, and so that's N is the number of pairs of data. Now, for this kind of hypothesis test, we don't use degrees of freedom. We just use the sample size. So that sample size is N equals 5, and we were told in the question, in the problem, to test to a significance level of 0.05. You can see there's only 2 columns in this table, and 0.05 is the first one, and our sample size of 5 shows us that our critical value is 0.878. Now, we compare the test statistic to the critical value in this way. If that test statistic, actually the absolute value of that test statistic, which means the positive version of it, if it's a negative number, but if the test statistic is greater than the critical value, we reject the null. If the test statistic is less than or equal to the critical value, we fail to reject. Well, in this case, the test statistic that we got in our summary output here is 0.591. That's the multiple r, that's our lowercase r. And so that test statistic is 0.591. It's less than the critical value, which is 0.878. So we fail to reject the null hypothesis. Now, here is a visual representation of how we make this determination. The critical value here is 0.878. The negative version of it, if we had a negative correlation, is down here at negative 0.878. And our sample statistic is here in between. These are the rejection regions, and this is the fail to reject region. So that's our hypothesis test. We fail to reject. If we fail to reject, there is not sufficient evidence to support the claim. So we're done with part B. Now in part C, we're asked the proportion of variation in y that is explained by the least squares regression line. And that is just this r squared. And of course we could put that in our calculators and square it, but Excel has very kindly done that for us. And so we see right here that that's r squared, 0.349599, so I rounded that up to 0.3496, and that is the proportion of the variation in y that's explained by the least squares regression line. So that's those pieces of our question on our take-home. And then the next thing that we're asked to do, I believe, is to find the linear regression equation. And I'll pause here to say that if we're asked what the percentage of variation in x or y that is explained by the linear relationship, we just move the decimal point 2 places and we have 34.9% instead of 0.349. This would be a good thing to keep in mind. Correlation does not imply cause. Okay, now we're going to move on to regression. And if you look through these slides, there's some interesting points to be made here. This shows you the algebra that you would use to determine the slope of the linear regression equation and the y-intercept of the linear regression equation. But, and this by the way, this y bar is the mean of the y values, this is the mean of the x values. But we can use XL to do this, and just cut straight to it. We can cut through the chase. Here's, like I said, here's the algebra. Here are those calculations. We see that our slope is 1.72745. We can see that our intercept is 125.40740. And these are the same coefficients found in Excel's regression function. And here they are. So here's the equation. This is our linear regression equation, and you can see that the intercept right here is right here, 125.407. I just rounded it to an integer. And our slope is what's labeled x variable 1. And so if you see this, if you locate this portion of the regression analysis report, which is right down here, then you can find those values, and there you have your regression equation. Now, one of the next things that we're asked to do is to predict what the height of a man will be if his shoe print is a certain length. And you might want to look at this right here. This is a clue to what you want to do with one of the questions in that take-home. So the equation that we found in this example, because the correlation is weak, it's not suitable to make good estimates, but we're going to pretend like it is for this example. And you see down here it says the question on the take-home gives us a much stronger correlation and a much better equation with which to make our estimations. So we have these shoe print lengths and these heights, and we've got our regression equation, and we're asked to estimate or predict the height of a person with a shoe print length of 29 centimeters. Well, that's an x value, so we just plug that value in for x in our equation, and after we calculate that, we get 175.17 centimeters. That's the best estimate we can make using this equation. So I believe that covers everything for the question. And as I said, the slides are posted. You might want to look through them, see if there's any minor point that you might have missed, or see if there's some valuable question you might want to ask. But I think that just about covers everything.